All right, moving on to our thyroid gland. It is what's often described as a bow tie shaped gland. You can see this in this image. It's in the throat area, just underneath that thyroid cartilage. This would be that large Adam's apple in males and a much smaller one in females. So it's on either side of the trachea. It has a very, very good blood supply, again, because it is going to be an endocrine gland. So a follicle in the thyroid gland is one of these, I don't know, like a roughly ovally cube-shaped structure here. You'll notice the outline of these purpley cells and then this pinker middle part. This pink middle stuff, that's the actual thyroid hormones being stored in the follicle. These cells are simply follicular cells. So the thyroid hormone is one of our main hormones that's responsible for our body's metabolism. You can see this in infants. It's critical for proper brain development. There are two thyroid hormones. There's T4, thyroxine, and T3. T4 is largely inactive, so T3 tends to be the more active version. So T4 is converted into T3. And again, the big thing here that I want you to be aware of is that it's going to be important in your body's metabolism. So again, in the building of different parts and in growth, that'll be important enough. There's a lot of different functions to the thyroid gland. I'm not going to get into all of them. But one of the other things that's going to be important here is that in between these follicles, kind of like in this corner here, are cells called parafollicular cells, and these are going to be producing calcitonin. So again, that hormone that's going to put calcium from our bloodstream back into our bones. Now, on the back side of our thyroid gland are our parathyroid gland. So this is now, like if you look at this image, it's a posterior view. So this is the back side of the thyroid gland. There are these four. They're about the size of a little green pea glands. Those are our parathyroid glands. And parathyroid glands produce something called parathyroid hormone. Not surprising, right? So let's just follow this because, again, these will have an antagonistic effect. So let's just say there's high levels of calcium in the blood. That will stimulate the thyroid gland and the parafollicular cells in the thyroid gland to release more calcitonin, right? So you'll see step 2, calcitonin will stop osteoclasts, if you remember back. Those are those cells that break down bone, thereby decreasing blood calcium levels. Okay, so then we get this feedback loop. Now, if those levels of blood calcium get too low, that's going to stimulate the parathyroid gland to release parathyroid hormone. Going this way. Parathyroid hormone will cause a reabsorption of calcium from the bone, meaning it will break down bone and prevents the loss of calcium in the urine. So we saw that in the last lecture. So under parathyroid hormone, we're going to reabsorb calcium before we lose it in the urine. Parathyroid hormone will also stimulate the kidneys to release calcitriol. Calcitriol, this is the active form of vitamin D. This stimulates the absorption of calcium from food in our digestive tract. So both by breaking down bone as well as causing the release of calcitriol, we will increase our blood calcium levels. Okay, again, until they're so high that then calcitonin becomes more upregulated. Until blood levels of calcium become too low, then parathyroid hormone takes over, and so on and so forth. And between the two of these things, we're getting, can you see how they start evening this out? And again, these are not these wild fluxes in your body of high levels and low levels and high levels. You're maintaining, again, a general average homeostasis. Okay, our adrenal glands sit above our kidneys. So again, adrenal glands. These are producing 4 different things. So mineralocorticoids or aldosterone. We've seen aldosterone already. Glucocorticoids, which there's 2. There's corticosterone and cortisol. Cortisol is we produce much more cortisol than corticosterone in our bodies. Androgen, so androgenic hormones, so testosterone in the female body, for example, is due to release from the adrenal gland. Norepinephrine and epinephrine. So if you remember back, norepinephrine and epinephrine, these are flight or flight hormones, or a couple of them. So they're going to increase like the strength and speed of our heart rate, our heart beating. So you can kind of see also how these are working all together during stressful situations. It kind of makes sense. Zombies are attacking. We are going to, our heart needs to move blood faster. Cortisol is going to have an anti-inflammatory effect, and it's also going to release sugars into the bloodstream, right? Because we're going to need that in working muscles. And then aldosterone is going to help us retain water to also increase our blood pressure. So you can see how the adrenal gland, even though it's releasing different things, they all kind of can work together synergistically. There are 3 different parts of the adrenal cortex: the zona glomerulosa, zona fasciculata, zona reticularis. Those different hormones are being produced in these different areas. So aldosterone, cortisol, the androgens, and then the medulla is what is secreting epinephrine and norepinephrine. And here's just a reminder, you've already seen this chart in the pH and fluid balance lecture. But again, just as a kind of a quick reminder of aldosterone. So if we have dehydration, a sodium deficiency, or hemorrhage, we have a decrease in blood volume, we're going to have a decrease in blood pressure. This causes our kidneys to release renin, which will take the angiotensinogen that's being produced by the liver and convert into angiotensin 1, which then gets further converted into angiotensin 2 by angiotensin converting enzyme found predominantly in the lungs. That angiotensin 2 is going to stimulate the adrenal cortex to release aldosterone. Aldosterone is going to increase our sodium reabsorption. Wherever salt goes, water follows. And if we have more water being reabsorbed, we're going to increase our blood volume, and we're going to increase our blood pressure. Okay, so just as a little quick reminder of aldosterone. Pancreas, we've seen this also in the digestive system, so some of this is going to be reviewed. So we have the head of the pancreas, the body, and then the tail. As a reminder, most of the organ is producing digestive enzymes. However, we have these areas called the pancreatic islets that are going to produce hormones. These are the hormones and the cells that produce them. I wouldn't worry so much about these percentages. That's not what's important. What is important that you understand that alpha cells are producing glucagon, and glucagon is going to increase blood glucose levels. Beta cells are producing insulin that will work antagonistically to alpha cells and decrease blood glucose levels. Delta cells produce somatostatin. This is going to suppress the secretion of digestive hormones. And then F cells produce pancreatic polypeptide. These are going to stimulate chief cells in the stomach, and they're going to decrease pancreatic and bile secretions. So the main thing, again, not these percentages, but the cells, what they produce, and then what they do. All right, that's a lot of information. So I'm going to stop right there. And as always, if you have any questions, please let me know.